you just lose the side screen as well. Minimize the one on the right. Cool, great stuff.
Your first one, is it? First slide?
Yeah.
Right, we all ready?
Rock and roll.
Well, thank you for having us. I'm Justin from Solar Ceramics. I'm your day-to-day contact for samples, projects, questions. Ken's our sustainability manager. He's going to be hosting this. So as I say, we're the #1 architectural power supplier in the UK. But today we're going to be supplying knowledge through Ken. So
No pressure.
no pressure. I'll hand you over to Ken. So we get on with it.
All right, cheers. So this does take an hour, and it is pretty heavy going. Okay, we cover a lot of ground. We start quite high, environmental stuff. We have to talk about the problems, and I'm sure a lot of these things we talk about you're already familiar with, so it might be a bit of a reminder. And then sort of the second half is more about solutions. So first thing, obviously, thanks very much for having us. It's great to see you folks here. I've visited your offices in Manchester, and I've seen some of your colleagues out socialising. Yes, a few of your colleagues have been to our Manchester showroom as well. So it's lovely. The EPR family, it's great. So what's all this moving earth thing about? Well, first thing I want to say is that this has really impressed me. Okay, it's been amazing what you've done here. This is the 146th practice I've visited, and you get top marks for all of this. Okay, so well done. I'm not just saying it, it's really good. The oldest thing in the room is probably this, much older than me. And we've got a ceramic tile here. The ingredients of this, millions of years old. We've got feldspar, which is about 60% of the Earth's surface, means field crystal. Now, there's a clue there, field crystal, it's linked to glass. So there's vitrification taking place when we make these. It's a high temperature chemical reaction. So you imagine trying to get this glass back to sand. Very, very difficult. It's the same here, very highly intensive energy process going in. Obviously, we've got clay in it. About 12% of the Earth's surface is clay. It's an old term for sticky, if you know where it comes from. And of course, we've got sand as well. And these are easily accessed from the Earth's surface. It basically comes from where the old riverbeds were. Production techniques, we know that ceramics have been around for thousands of years in all its different forms. And they have evolved. And you folks know very well, and you can talk to my colleague Justin about this in more detail, but the application for tiles is quite amazing. But I come from a sustainability background. And when I joined the company, the first thing I wanted to get my head around is, what is this material? How does it compare to other materials? Now, we've made a choice, obviously, to no longer walk on grass. We don't live in caves anymore. So we made a choice to put some sort of material on the floor to live in, to work on, to play on, etc. Yep. And I just want to share some thoughts with you. It's all backed up by a master's thesis that I completed back in October. And I've basically analysed the carbon footprints of the lifespan of buildings of flooring materials. So why it says, when we're going to be talking about ceramics, I don't talk an awful lot about ceramics, more about materiality. Okay, so hopefully you'll find it interesting. So I'm glad you've all got something to eat and something to drink, because the key messages can be a little bit depressing for the first sort of 10 minutes. So please keep your spirits up. I'm just the messenger. Okay, so the first message I'll be talking about really is that we've got some skin in the game here. This industry, the building industry, is responsible for around about 30% of CO2 emissions. So we need to accept we've got some responsibility here, and I'm going to be talking a little bit about that. The second thing is I want to go through a little bit about terms and definitions. They're a little bit confusing, so hopefully a little bit of an eye-opener thing there. And finally, and I think this is the most important thing, ceramic tiles, of which porcelain is a type of ceramic. It's just a finer powder, finer clay, a kaolin clay, get more material into a square meter, hence it's denser, it's heavier, a bit more expensive. But basically any sustainable material that lasts a long time, that's got a low carbon footprint for the lifespan of a building, I do believe it can actually help reduce the carbon footprints of buildings. And that was the main content really of the thesis that I completed. So I'm happy to send you a copy of that. So like I said, we get off to a little bit of a doomy start, so I do apologise. We're going to be talking about embodied carbon, that's locked in carbon. Everything that we see around us is tangible, locked in carbon. Okay, it's tangible, it's physical, but we're also going to be talking about operating carbon as well. And that's obviously the lighting, the heating, the ventilation. You've got lovely, lovely clean offices. So obviously these are clean, that's part of operating carbon. So first thing I really want to share with you is this. We've definitely had a negative impact on the planet, as I'm sure you're aware of, but just to correct a few things that people are, I guess, publicizing throughout all the different communication channels. People say it's about saving the planet, saving the earth. And they mean well, but it's not actually about that. It's about saving diversity, about living things. We need to care for the planet. We need to care for the earth. We lose sight of it. We've been here, you know, that amount of time on this planet, and we're on a ball of minerals. We're mineral-based. We're about 18% carbon. We're surrounded by atoms, different elements. And we're actually in the sixth phase of mass extinction. We're in the Anthropocene period. This ball of minerals has gone extinct about 5 times previously. It's a survivor. It's living things that we need to look after, and we're losing sight of that. So, like I say, a little bit of a homework thing, but we're perfectly positioned from the sun, right amount of heat energy, right amount of light to generate life. We created a greenhouse effect because we started to generate greenhouse gases naturally in the animal kingdom. That's methane and carbon dioxide. And we need the greenhouse effect. We wouldn't be here if we didn't have it. It traps the heat, avoids us from freezing, it gives us life. We're going to talk a little bit about the carbon cycle in a second. The water cycle is sort of like behaving itself today. We're doing well. These are the gases that are really contributing to this global warming. Now, right at the top there, that actually says global warming potential, GWP. And you'll see those letters in the presentation. You also see the letter E after CO2. That stands for the equivalent amount of carbon dioxide lasting 100 years. When we emit these gases, it's not up for a few weeks, it's 100 years swirling around all the time. CO2, we exhale it. Excuse me, I mentioned before, we're carbon-based. We actually exhale around about 5 kgs of CO2 every week. It's about 200 kgs a year. But obviously we burn fossil fuels. That's in solid form, in liquid form, and gas form. Now methane, CH4, that's escaping from the planet all the time. It's a major problem, actually. But also, we have a tendency to love red meat on this planet. And the rearing of these animals and all the crops that we grow is adding to this CH4 problem. You may or may not be aware, but the UK government has actually signed up for the UK to be net zero by 2050. It's under the IPCC Act. Now, to be truly net zero, it includes all of those gases. Now, we've got about 9 million heads of cattle in the UK. And they all exhale around about 100 kilograms of that CH4 every year. So it's a significant problem. But you never hear these things talked about. So it's just carbon. So I want you to be aware of the difference between carbon net zero and net zero. Okay, it's really important. We also produce a lot of methane because of some of the things we've got here. Food packaging, we don't really know what to do with a lot of our waste. They tend to go to landfills or get incinerated, and the bacteria live off it and they generate a lot of methane as well. N2O, that's nitrous oxide. We get that because we make nylon products, but also we make a lot of nitrates to accelerate the crop growth to feed all these animals. So it's kind of like a double whammy with the red meat thing. Apologies for people eating red meat, by the way. I don't make you feel uncomfortable, but I'm just sharing that with you. SF6, really weird one, sulfur hexafluoride. We use that to stop our electricity networks from exploding. There's lots of high voltage switching taking place and it stops the explosion. And look how much of an impact that has. So this has led to increased global warming. So that's the cause. The effect is climate change. And we're going to be taking a step through some examples. But it all impacts on this, biodiversity. Now, you folks have got the smarts to house humans anywhere on the planet. Bottom of the sea, top of Mount Everest, on the moon. Because you know how to control environments. Aren't we clever? Are we? Because the rest of the animal kingdom can't keep up with us. They can't do any of that. So we kind of like see all these, well, we kind of see the problems. There are some signs out there, you know, actual visual signs. Most of it's what we feel. But the rest of the animal kingdom, they cannot react. So our superiority is causing these problems. I mentioned before about it's exhaling CO2. We're going to be talking about carbon footprints now. If we actually think about the amount of CO2 we release, and I think there's some examples kind of out there. Yeah, see, there's a lovely big tree just outside here, but it's not got any leaves on, has it? So it's not absorbing any CO2 at the moment. So we rely on that CO2 to be absorbed elsewhere in the oceans, mosses, and the Amazon. When that is in leaf, we would actually need about 10 of those trees to manage our own individual carbon footprints. That's 10 trees per individual carbon footprint. Right? That's the normal carbon cycle. But our production of CO2 and all those other greenhouse gases, as a result of the way we live our lives in the Western world, actually means we need around about 400 trees. So that's a 40 times difference. And I'll demonstrate why that's happened in a graph shortly. So what is sustainability? This is a common definition you will read. It's about meeting our own needs now without compromising the ability of future generations to meet their needs. Forward planning, looking into the future, yeah, pretty straightforward. Major flaw in that statement, and it's the word needs. I purposely left it as this definition so we could talk about it. When were we last needs driven? Now, there's some people that still very much have to be needs driven because of their ability to live their lives. But on the whole, most of human society are more wants driven now. And we've been sort of sucked in through marketing, which was invented in the 50s and 60s. Brand positioning, product leverage, price points, more choice. We've become absolutely swamped with choice. And that has caused a massive problem on this planet. That definition not being quite right. It's kind of like bundled up with these three circles. People talk about this all the time: environment, economy, and social. Now, if we were stranded on a desert island, first thing we'd do is make sure we're all right. Nobody said, yeah, but push ourselves down over our tech stock. Make sure we had a common language so we could communicate. Then the chances are we'd find out what our strengths are, our weaknesses. If we're allergic to anything, have we got a builder? Have we got a doctor? Have we got a graphic designer? I don't know. We'll be working things out. So we'll all be on the social scale of things. That's the first thing we do. The next thing we do is we think about the environment. Have we got a safe place? Are we protected from the sun, from the rain, from the wind, dangerous animals? Have we got water? Have we got food? That's the environment. When do you think we'd start talking about economic issues? Very unlikely, unless we found another island 100 meters away and we could trade with them. We wouldn't really talk about it. Yet right now, everything we do on this planet, particularly in the Western world, is driven by economic factors. I would hazard a guess that most of the reports you get in your business, weekly, fortnightly, monthly, whatever, same as we do at Solus, the reports are, this is how we're doing at the moment, this is our pipeline. We need to know we're going to be healthy as a business moving forward with profits. Profits, not a dirty word, profiter, actually to enjoy life in France. But you can see how it's all reversed a little bit. So I get it. We all get it. The economy is driving a lot of things we're doing. And we are social animals by default. However, we know the environment is really important, but we're struggling to deal with it. We really are. And we need to do something about it because there's some issues here. So back in 1900, we started recording global increases. We have actually broken 1.5 now. I started these presentations about 1.5 years ago. And at that stage, I was saying we're nearly at the 1.5. I'm now saying we've crossed it. So I myself have experienced my presentation changing. But this is the scary thing, going on to another 30 years, an extra 1.5. So everybody's talking about leveling things off, just stopping it from getting any worse, just trap it as we are now, just hold the ship steady. So people are talking about net zero carbon, net zero and carbon neutral. So I'm just going to very quickly explain the differences. So carbon neutral was the first one off the rank, right? Very easy to understand. Carbon neutral is basically, let's measure our carbon footprint, and then let's plant some trees that will absorb the equivalent amount of CO2 that we release. Now, we don't plant trees, we actually plant saplings. These saplings take about 5 years to start absorbing any CO2, typically about 5 kgs. It actually takes 10 years for the cellular structure of a tree to actually start absorbing anywhere near about 10 kgs. Never mind the 20 kgs that these sort of trees are absorbing. So the brand, or the service provider, whatever you want to call it, that says buy from us, we're carbon neutral, we planted some trees. For the next 10 years, those emissions have been going out, finally catching up after 10 years. And the chances are not all those trees made it, typically 10% die. So just be wary of that one. Carbon net zero is measuring the footprint, but making an effort to reduce it on a carbon basis, looking at what the carbon output is and then reducing it. And then rather than relying on nature, the planting of trees, which is still good, I'm all for planting trees, of course. Rather than do that, we're relying on technical fixes. So this is more of a scientific approach. This is investing in wind farms, solar generation, or improved energy efficiency techniques. It tends to be more in the sort of underdeveloped parts of the world because they need more help. That's net carbon zero. Now, net zero are all those gases. It's the same thing, reducing. So please, whenever you're talking to anybody on your travels at work and social life, family, whatever, and people start talking about net zero, just make sure they know what they're talking about. Because most people say net zero, but they're just thinking net carbon. Does that help? It's actually the big picture net zero. And I mentioned just how many heads of cattle we've got, a major challenge. So this is the gloomiest slide. So give us a smile, please. Just prepare for it. Okay. So for every 1 degree increase, these are the sort of things that are going to happen. A lower glacier mass at the top of the Arctic Circle. It's happening on the Antarctic as well. This has actually happened now. You're probably aware that our planet's got 2 strong polar vortexes from each end of the planet. They control all the wind patterns. Now, ours is oscillating from the stratosphere down to the troposphere. It's oscillating, it's shifting, and it's affected the jet stream. And that's pulled the cold pressure, the low pressure from the Arctic Circle and dragged it, and it's changing everything. If you want to understand what this impact is, just cast your minds back to last year when we were looking forward to summer. June came along, hottest summer on record, really hot, hottest one on record. And then it went, July, it wasn't lousy. It was really miserable. It was damp, it was cold. It was like, well, where's the summer gone? That's because the jet stream had moved right across, dragged all the cold pressure over our island, condensing all the high pressure over Europe, making it a hot box. And then it went back and it oscillated again. And then the first week in September, we had a heat wave. It's the same thing. And it's happened in winter. Winter's been very mild. One of the mildest Januaries we've ever known, and a mild February. April is supposed to be the month of spring, when we're supposed to be seeing all the buds and the cookies coming over from Africa, etc. If it happens in March, it's known as obviously an early spring. But we've heard cuckoos in this country in February, and we've seen flowers budding and blossoms coming out in February. And it's a real worry. We've got some good weather now, but if we get a cold snap and it lasts for 2 weeks, really cold, freezing weather, and those buds die, particularly the flowers, we're in trouble. Because they won't come back. The bud's got a chance to come back. Bleeds can often get back, but the flowers, they really struggle. And of course, we need all that for pollination. So please be mindful of these things happening. There's more cloud density around at the moment. I don't know about you, but I actually find it's more humid in the UK right now. Don't you find it's more humid? You're sweating easier, you go on the trains, there's more condensation everywhere. Higher sea levels, definitely a risk to life. It's sad, but it's true. You know, we're getting people that have obviously lost their lives through flooding, but also through extreme heat conditions. And the good old Mozzie's been here for so long, they're going to love all of this, you know, spreading diseases. So how did we get there? Now, back in 1900, our population on the planet was around about 2 billion. We're now at 8 billion. 6 billion population growth in just that period of time. And that takes into account 2 world wars. Massive. Now, if we were to measure our footprint just around all emissions, it'd be way down. It'd be around about 2 gigatons at the bottom down there. Really low, but you can see it's much higher than it needs to be. So we've generated additional CO2. So how did we get there? Now, before 1900, we had the Industrial Revolution. That kind of kick-started things. We had the ability to make things. We were still using hardwoods. We took all our hardwoods out in the UK, part of the reason why we formed the British Empire. So we get the woods over from Canada and New Zealand to carry on building with hardwood. And we had the steam and the coal. But in 1900, a material was invented that changed everything. And we would not be here right now without this material. And it is cement. And right now, it still contributes 8% of all global CO2 emissions. You imagine doing your job without cement, you know, added to concrete. It's everywhere. It's bonded all these bricks together, all the supports. Now, in the 60s, we did a silly thing. We did a double whammy, okay, as humans. First thing we did is we created pesticides, which sure got rid of the pests, but actually killed all the good bacteria in the soil. We created dust bowls in America and Europe, and that caused some major problems to the climate. And then we started to deforest the Amazon. Now, when I mentioned before about this tree not absorbing CO2 at the moment because its leaves aren't there, a lot of the CO2 that's being generated is being picked up by the Amazon. It's like that central base all the time. Big, broad tropical leaves typically take about 40 kgs of CO2, twice as much as that. And yet we've already taken 25% out. Crazy. So we increase it and we reduce it. Now, this was major. In the 70s, we discovered plastics, and it was massive. It was such a discovery because now we realized we could do something else with fossil fuels, not just using it for petrol or for barbecue gases. We could get a level of gases in the middle called the naphthene gases, turn them into chemicals and create plastics. And boy, oh boy, did we fall in love. Great technology for packaging. It suddenly meant that we could have lots and lots of choice of food. Food was going to be safer. We could store things longer, more choice. But then we got into fashionable things in the home and on our bodies. All of a sudden, clothes became very cheap. Carpets were everywhere, curtains were everywhere, new seats. We just got carried away with plastic. We fell in love with plastic and we didn't really think about the consequences down the track of doing this. So I'm a fan of plastic, but I'm just going to share some things with you that really, really worry me, and hopefully it resonates with you as well. Why we invented crap is beyond me. I just don't get it. Why did we make so much stuff out of plastic when we really didn't think it through? And we're going to give some examples of that in a bit. It meant we could make cars really cheap. Mass production of cars. They were expensive until plastic came along. Of course, more cars, more emissions. This was the single most important thing that happened in our generation. This was the thing that actually broke it. I would say it broke the planet, to be honest. As soon as the Red Wall came down in China, great strategic move by the Chinese government, opened the doors, cheap manufacturing. All the Western manufacturers flooded over to China, got their things made at a fraction of the cost. All the emissions went with them. We didn't lose any emissions, we actually grew the emissions. Because in China, they use mainly brown coal for making their electricity. Still about 60% of all electricity made in China is made from brown coal. And we loved it because of that statement I shared with you before, need versus wants. Now, all of a sudden, we could have more choice, cheaper.
Can you explain the difference between brown and
I'll do it at the end if you like. So brown coal is basically an inferior coal to a black coal. It's got less anthracite, so less carbon value, so therefore less thermal energy is released for making the steam. Okay, do you get that? Cool. Right. Yeah, we had this love affair with all this choice, and we have created this monster. It's not China's fault, it's our fault, this Western world, for wanting more things as cheap as possible. And the Chinese economy absolutely exploded, as it would. They went from a third world country to they're now the second most powerful country in the world. Look at the trebling in the carbon footprint from 3 tons to 9 tons between 2000 and 2020, 20 years growth. This is the scary one. Just in 7 years, 2013 to 2020, we saw enough CO2 generated in China, 80 billion tons, just in that 7 years, which was greater than the whole of the emissions generated by the UK, by Great Britain, since the start of the Industrial Revolution. Just that 7-year period. So it's a major contributor, and it still is. We represent less than 1% of CO2 emissions on the planet, UK. China's way up there. It's like 30–35%, something like that. It's massive. And no wonder, because of this. So they could afford cement, they could improve all their infrastructure. 2020, the planet took a breather with COVID. You can see it was the largest reduction recorded. And then we had the largest increase because we went back into our normal ways. Now, I want to really get you thinking now about this shift that we've had between natural materials and man-made materials, okay? Look around this room, there's quite a few lovely sort of natural mineral materials still around, but I'm still seeing quite a few man-made ones. This is a really good example in here of avoiding man-made. You've done a good job in here. So just as a little bit of a brief exercise, let's just talk about plastics. There are 2 basic types of plastics. I'm not talking about the formulas, polystyrene, polypropylene, etc. I'm talking types. Plastic means it's plasticized. Plasticine, you remember plasticine? Same thing. So what's happened here is all the monomers are bound with the polymers, and they're flexible. Think about weaving. The clothes you're wearing are woven together, aren't they? Cross-stitch, yeah? It's like that in the plastic world. So the polymers have been woven in such a way that they're flexible. Some are really flexible, like plastic packaging, cling film, etc., and some not quite as flexible. But because they're flexible, they do stand a slightly better chance of being recycled because the polymers will give themselves up easier. Now, the other type are the thermosets. It's a hard material. Harder material, harder to recycle. This is kind of like the glass example I gave you and the ceramic tile example I gave you. There's a strong process taking place here to bond these really, really tight. So it's very, very difficult to recycle them. And they're everywhere, okay? Particularly in carpets. So I'm just going to talk a little about carpets. When we first came out with carpets to replace the wool ones, because now we could afford them made out of plastic, there were the polypropylenes, and they're still around, just one type of polymer. Now, in the world of recycling, we hate 2 things. One is contamination, which is like waste, oils, greases, fats. It contaminates the material. And the second thing is loss of polymer integrity. And that means we've mixed polymers. We've got a mismatch, a soup of chemicals that makes it very difficult to recycle because we need to get all the polymers back into their individual family groups. So these took off. But then we realized that we can make them last a little bit longer, maybe an extra 2 years by adding things to it, and that's caused us some problems. So right now in the UK, the amount of carpet that is taken up every single year, used carpet from homes, from hotels, from offices, etc., is equivalent to the size of the city of Birmingham. That's how much is being taken up every single year. What percentage of that carpet do you think is being recycled? Participation. Damn, go for it. 2%? Spot on, well done. Have you just read something on the news this morning? Yeah? Nobody's ever got it first time. Well, 2%. 2% is being recycled. And that 2% that's being recycled is the single polymer structure, the polypropylenes, or just the nylons, just the acrylics. The rest, the 98%, is all the mixed stuff, which has caused us problems. So what's happening to that 98%? What do you reckon's happening? Landfill? Any other suggestions? Send somewhere else. That's a very common one with the recycling in the UK. It's actually being burnt. 75% of it is being incinerated. So I want you to just imagine that 75% of the city of Birmingham being incinerated every single year because we don't know what to do with it, because we've mixed all the polymers. It's incredibly difficult. It's incredibly difficult. A little bit of it goes into other things. We use it for horse arenas. We also put a bit into wet cement to try and improve the thermodynamics. You want to know about U values and R values yet to improve the thermal resistivity? Yeah, so we put it in cement. But some of it is going to a landfill. And this is a problem because when it goes to a landfill, over time with pressure, erosion, humidity, these fine fibers can break away. It's called leaching. And if we've got an older landfill that's not particularly well sealed, this leaching allows these fibers to go into the waterway through the water table, join all their buddies at sea. And we already know we've got plenty of plastics in the sea already. We are surrounding ourselves with plastics. In particular now, a problem that's rearing its ugly head is microplastics. These are any like molecules of plastics less than half a millimeter. And I hate to say it, but they are everywhere. They're in our water now. They're in the rain, right? It's coming through our bodies. These are the two extremes I want to share with you. If you've chosen a life where you try and resist plastics, so you may have a wooden floor, cement floor, ceramic floor, whatever, wool carpets, cotton seats, leather seats, wearing cotton, linen, leather. I know there's like vegan issues, etc. Wool, yeah, all the natural materials. Your car's got leather seats, whatever. When you go to eat, you perhaps eat from cardboard, or you're using aluminium or ceramic, wooden knives and forks, or steel knives and forks. You're not exposed as much. So probably about a grain of sand's worth of microplastics are going through your body every single week. However, if you're down this end and you've been caught up with the fashion world where things are fast, things are cheap, things are stylish, we can turn these things over quickly, you're being exposed to more plastics because they're typically cheaper. So we're talking plastic clothing, plastic shoes, plastic seats, plastic curtains. Yeah, you can imagine it. Yeah, it's a lot of it about plastic takeaways. The chances are you've got a postage stamp's worth of microplastics going through your body every single week. Now that's now. Now, one of the things about plastics is they're incredibly resilient. This is going to have a cumulative effect. It's going to get worse and worse and worse over time. So please just have a little bit of a think about things. Now, nothing gets away without having a carbon footprint. Now, all the natural materials and the man-made materials, they've all got carbon footprints, but I'm just getting you thinking about the consequences of what we've done, not understanding how to use these polymers. So what about vinyl? What about LVT vinyl? What percentage of vinyl flooring do you think is being recycled in the UK? No pressure on you because you got it right first time, but what percentage? Higher or lower? It's lower. 1%. 1%. And that's because it's contaminated. So I want you to have a think about this. Right, I think we're actually walking on it right now. So have a think about all this plastic that we're putting down. We think it's a great idea, but we don't know what to do with it when we no longer love it. We're essentially investing in modern coal. We are investing in modern coal. That's all we're doing. When it comes up, we're just going to burn it. If you go for a walk this weekend, you will not see plastics, in the woods, unless people have been fly tipping, but you'll be presented with nature, with wood, with soil, with earths, with metals. You see it in nature. Okay. It's important because we're supposed to participate in a natural environment. What we've done is we've been conditioned, brainwashed, all of us, into consuming in a constructed world. We consume, we consume, we consume, we construct, we construct, we construct. It's what we're conditioned to do. Yet we are really of the earth, but we've lost sight of it. So as a little bit of an exercise, have a look in this room and try and find some things that are still entirely natural. See if you can spot things. Any? Timber, yep, that's timber, yeah, it's just been honed a little bit. Definitely I'll give you that timber. So we've got some wood, cellulose. There are some lovely examples. Yes, unless someone's had work done. Nobody's had work done. No. Okay, cool. I've got a cat too, so I'm partially. We've got. Phone's gone, by the way. Oh, it's just come back. No, marginal orange juice. We'll give you marginal orange. So water. If you've got any water, definitely. But you've got lots of. There was a plant. I saw a plant in the corner. So you've got a plant there. So we don't have a lot of nature around us, do we? And it'd be difficult if we tried running this session in a forest yet, wouldn't it? But you know, that's the extreme. However, there's lots of things around here that are made from natural minerals. So we've got loads of cellulose. The wood here is absolutely beautiful. Love the wood, love the wooden chairs, magnificent. Love all the clay everywhere, all the bricks. We've got mortar in the middle. We've got some glass from sand. So we've got minerals and ores and cellulose, which is the wood family. And it's all around us. You've done a great job here. And I'm hoping that maybe something like things are aluminium, speakers are aluminium. You've got felt, you've got some felt, which is cool for your acoustic panels. You've got some ceramics on the back there. So we've got lots of things around us that are still of the earth, that are natural minerals. I'm pleased to say you don't have a lot of man-made stuff here. Going some places, I've seen plastic plants growing with that. I've seen polyethylene tables. I've seen polypropylene carpets. I've seen everywhere. Now, obviously, we've struggled to make this projector out of hemp, you know, or wood. So I get it. We need plastic for certain things. But just have a think about these choices you're making. Sustainability really supports more nature-based items, materials, instead of some of these man-made ones. If you've got a choice, just have a think about it, because we're struggling to cope with the consequences of these decisions. So we've talked about the problems. Let's think about solutions now. You know that an awful lot of carbon in your buildings are going to go into the superstructure, all your big columns, your beams, you know, your RSJs, a lot of cement, a lot of steel, etc. We know that. But then when we start to break it down and actually get more into sort of like the substructure and the facade area, it makes up quite a decent part of the footprint. Now, the largest organ on the human body is actually our skin, because it's by area, it's large. And in your premises here, take away all the brickwork, which is very, very dominant and beautiful, I must say. You made a choice to use a lot of plastic and acrylic in your carpets. Have a look at your carpets. They seem to be acrylic based. And you've got some lovely old tiles in the entranceway. So you've got a bit of a mix match here, but you've still used an awful lot of plastics. I don't know if you did it or the builders did it and you just came into it. I don't know. But we are all responsible for these decisions. And sometimes we make these decisions because it looks great, it's cheap, it's going to be durable, and we don't think through the consequences of what's going to happen next when we no longer love that thing. So it makes up a significant part, flooring. We need to consider that. Now, REBA are behind it. They're trying to get the emissions reduced by 40% by 2030, just 6 years away. That's residential, 1,200 kgs per square metre of CO2 equivalent, down to 625. Schools, 1,000 down to 540, and offices, 1,400 down to 750. They're just examples. Now, I want to stress this is all voluntary. There's nothing regulated here. It's up to us, the industry, to make these things happen. It's a big challenge. We're seeing additional growth in building stock. This is from the World Green Building Council. We're going to grow by an extra 2 billion population by 2050, and they're predicting a doubling in building stock. The United Nations actually reflects this. If you track the United Nations Green Monitor, they will tell you that around about the size of the city of Paris is being created in new buildings every single week on this planet. This is going over old stock and on green fields. So it's big business and it's big emissions. And it's a massive challenge because we're going to be building more, but we're supposed to be reducing our carbon footprint. 40% reduction in just 6 years' time, folks, and net zero carbon by 2050. So big challenges ahead in our sector, and how are we going to get there? Remember, it's all voluntary. So I want to talk a little bit about the process of moving earth for tiles. So if I say life cycle analysis, I'm going to talk about the ABCs of an EPD. How many of you know what I'm going to be talking about? Great. Okay, we've got a few. So an environmental product declaration is really important. It's the only certificate we've got that gives us the product identity. It's like its identity card. And the first three phases is all upstream. Now, all EPDs, environmental product declarations, they should know this because this is their business. They make things. A1 for a tile is getting the material out of the ground, typically 5% of its footprint. A2 is moving the material, another 5% of its footprint. For a tile, 90% of its footprint is making it because it's fired. Yep. Now, we also supply cement-based terrazzo tiles because these are cement-based. There's a chemical reaction taking place. So A1 is the greater number now. That's 80% of its footprint, 5% moving the material, and 15% setting it, drying it, basically. So whenever you're working with materials or products, work out if it's going to be chemical-based or production-based, okay? And that's with the ends. So we've made the material now, ready to be used, it gets transported, it gets installed. So now it's ready to be used, right? It's going to be used. So usage leads to maintenance, cleaning, repairs, etc. That's the B part of the ABC. And the final part is C, the end of life. What do we do when we no longer love it? How long does it last for? How do we repair it, etc.? So for tiles, pretty straightforward. We tend to avoid tiles going down rollers to the heaters with gaps. As you can see there, we avoid that because we want all the heat energy to go into the material. Because what is wasted heat if it goes in between tiles? We put big slabs down and then they cook with high pressure water jets. We recover waste, heat, water. It's very efficient. Some of the heat's used to actually heat the offices, control their heat recovery systems. And a lot of the lighting for, a lot of the energy used for the lighting and the control comes from photovoltaic panels. We work with suppliers who have very high credentials in terms of how they manage their own carbon footprint as well as their product carbon footprint. We take pride in that. In terms of installation, you can actually reduce carbon footprints as well. Now, that is typically the carbon footprint for normal cement, 2.6 kilograms of CO2 equivalent for a square meter. You can reduce it to 1.26 by using low carbon cements. So there's choices out there. You can always find a way of trimming those footprints. Now, we've got down to the A5 stage. What about actually now doing, the end of life? I've got two tiles here. Tried to make them similar colors to go with the brand. Exactly the same price. Same thickness, same slip resistance, same style. You can't tell them apart, right? They look identical. Remember, they're the same price. This one here contains 40% recycled content. So on that basis, which tile would you tend to specify? The recycled one? And you're not too sure? Have you made your mind up? You're very quiet. Hands up who would go for the 40% recycled tile. One. So if you don't put your hand up, I'm going to ask you why you've chosen the other one. Okay, who'd go for the not recycled tile? So I'll take it everybody's gone for this, but some of you are a bit shy. Okay, so why are we going for the 40% recycled tile? What triggered your decision? Please tell me. Less carbon, why? We assume what? Where's the recycled material coming from? What does recycled mean? Recycled means to return to the cycle of life. So by default, it means something has had its life cycle, yes? Get it? We recycle boxes, recycle cans, recycle plastics. So the assumption is that because it's called recycled, it's come and it's been used from demolition sites. It's come from a demolition site, right? So it's a used tile, yeah? Is that a fair assessment? That's what we think about recycled content. Now that term is called post-consumer recycled content. Now that is not the case. That's not happening. It's very, very difficult to recover tiles from a site and disassemble them. It's just like the example I gave you with the glues on the LVT. Remember, I gave you big clues before about what recyclers hate, and that is contamination and integrity. We've lost the integrity of the material. It's still now bound with concretes and grouts. So we should not be calling them recyclable, circular, or cradle to cradle. Now, there's two basic types of recycling loops. One is closed loop recycling. So an example of closed loop recycling would be if nobody loves that Quarter magazine anymore, which you should do because it's a great publication. If it goes to be recycled, it's a wood-based material, yeah? It could come back as the magazine again. That would be closed loop. It's actually coming back as a publication again. To the Quarter magazine, but it's being used for high quality publication. If it was open loop, that Quarter magazine could go to be recycled and come back as this box. So we're still using the material, but for something else. All right, so closed, it's coming back as the same thing, open is something different. Cradle to cradle is basically saying, we've made a product, we're using it, and that's what we should be doing with all products. Why make them if we don't use them? So they fulfill their purpose, but then somehow they'll come back and they'll start their circle of life back in the cradle again, cradle to cradle. Now we have 2 tile manufacturers in the world that have got cradle to cradle certification out of the 100 manufacturers that are out there. I visited one of these manufacturers in Italy through a translator. I asked the production manager, what percentage of used tiles comes back from the site and gets turned back into a new tile again? Because they've got cradle to cradle certification. What percentage of those tiles do you think he said comes back into the factory? You have a guess? All right. I know these are tough questions. 0, zilch, nothing. And he even sort of smugly smiled when he said it. So why have they got cradle to cradle? Well, if the tile leaves the factory, leaves the gate, if it doesn't get contaminated, in other words, it doesn't fulfill its purpose in life, so why make it, but we won't go there. If it returned back to the factory, it could potentially get ground up and be made into a tile again. Extremely difficult. High temperature vitrification process, and it's got glazing on. So it's not being done. So I'm sharing this with you because I want you to remember this. Please be curious. Whenever you're reading any material about circularity, about recycling, about cradle to cradle, just don't read the marketing blurb. You know, you're all switched on cookies. Ask the question. Is that right? Tell me more. Ask for evidence. If you're not getting evidence that something is working, be suspicious. Please be curious. I'm not talking about greenwashing. I'm just talking about being sensible. Does that help? It's really, really important because there's lots of things out there. So if it's not post-consumer waste, what is it? That 40% is actually just pre-production factory waste. It's the bits of clay that fell off before it even became a tile. So it's called pre-consumer recycled content. Now that is an oxymoron. You know what an oxymoron is when a statement cancels itself out. How can something be pre-consumer recycled? Because recycled means it's had its life. So how can it be pre-consumer? Yeah? We shouldn't be confusing ourselves with these terms. It's crazy. So it's just the stuff that goes into the product that fell off. An easy way of understanding this is if you were to go and buy yourselves an apple pie tonight on the way home, all right? You eat Tesco's Express, wherever it is you prefer. You see 2 apple pies in the fridge, both packaged beautifully, same price, but one of the packages has got 40% recycled content on it. Which apple pie would you choose? Not the recycled one, no. But the chances are they've got some recycled content in it. Because when manufacturers make things, they've paid for all these raw materials, these resources. They don't want to throw it away. They've paid for it. They'll collect it and make sure it gets used. Whenever I make an apple pie at home, if I've got a bit of pastry left, I go for the bubbles. Yeah, you know what I'm talking about? Yeah. Same thing. We don't throw it away. So please be mindful of that. It's particularly frustrating because even BREEAM, God bless their cotton socks, they're giving porcelain tiles with a 40% recycled content and A+ rating on their green guide, their green book. So they're rewarding a tile that's been made using pre-production waste. Now, these are still raw materials. Waste is the enemy of efficiency. Waste of time, waste of money, waste of effort. Yet it's being rewarded here. The tile above it, it's been made 100% perfectly. No waste, not used any waste, just gets a B rating. So I am challenging BREEAM. It's actually part of my thesis that I mentioned earlier on, and hopefully we'll make some inroads. Now, it's not just me saying this. I do come from a recycling background, other things as well, building services and materiality. But I got in touch with the Turkey University of Applied Sciences for you. So you had an objective view, not just me saying this. And this is what they had to say. The use of recycled used ceramic tiles from construction waste is hardly found, mainly because of et cetera, et cetera. You can read it there. So this is waste material, okay? It is not something that is recycled or reclaimed. So please ask all these questions. Don't take things for granted when you read some of the material. Now, he's talking about land construction here, so it got me thinking, well, what's the story here? So if we do the normal diagram, we've got materials coming in, we process them, we make them, we use them. We've got a very linear model at the moment in the Western world. The 40% recycled content happens here. It's just reclaimed production waste, right? It's just spillage and test materials. When we make things, it's better to try and reuse them. So I'm going to share something with you at the end where maybe we can actually reuse ceramic tiles without wet laying them. So wait till the end to see that. We avoid waste. They're going to be repurposed, as the professor said, used in land construction. Can they be made into rod aggregate? And can we actually get a true recycling loop working? Can we actually get post-consumer content in there? Right? So we're working hard on that. So in terms of this repurpose aggregate, I got in touch with DEFRA, the UK's waste agency, and I asked them how much waste from aggregate is actually reused in the UK. You know what demolition waste is like? You see the skips? Easy to set the wood out, the plastic, the glass, etc. Now we're left with rubble, concrete, plaster, ceramics, yeah? What percentage of that waste do you think is being repurposed in the UK? Knowing that vinyl is just 1%, carpets are just 2%, what do you think is the repurpose rate for rubble in the UK? Have a guess? Don't be shy. If somebody just said 50%, you'd be halfway there, wouldn't you? Because it's one or the other. All right, nobody's going to have a go. Okay, well, it is. Come on, click it. It's actually 93%. That's as high as it is. It's actually 93%. So we're reusing it. So this process of moving earth is good. We're using a natural material, natural mineral that's in abundance. It's down for a long time, and when it's no longer loved, it serves a purpose. No environmental issues. Setting fire to it, it's not leaching or anything like that. So EPDs are really, really important. If you're not aware of it, I'll quickly go through these. They are the only international standard document we've got to tell us the life cycle assessment, all that ABC stuff that goes into a product or material. They're guided by product category rules, so you can compare wood with ceramics, with carpets, with vinyls. And you folks can choose the most sustainable options. And at this stage, I just ask you, in terms of your own projects, how many of you have been asked for EPDs? How many of your suppliers have got EPDs? If they haven't, maybe they should be getting EPDs because we have to be transparent down the track. You cannot just rely on some marketing blurb. You'll need the actual scientific data, what goes into the products. That's why EPDs are important. Obviously, manufacturers can be very transparent with their information. They've got to be verified by a third party. You can't just make one up. They're valid for 5 years, and they help you get LEED and BREEAM points, and they're not cheap, okay? So there's some investment required. In terms of what goes into an EPD, obviously you've got the introduction, big picture, how it's going to be audited, how it's going to be covered, and what the caveats are. This is a really an important part of an EPD, the product category rules. They'll tell you, can it be recycled? What are the hazards? What are the terms? What are the measurements? And very important, they'll tell you what the typical lifespan is. And it's important, I'll explain that in a second. The methodology they're going to use, how they're going to carry out the assessment. They'll show you some results in tables. And a good EPD, if in doubt, go to the back of an EPD. They'll give you a very simple analysis at the back, a summary version, tell you the things you need to know, all the things we've talked about, toxicity, leaching, afterlife, durability, etc. Now, I just want you to be aware of this. It's kind of like the thing I was talking about before. Just be curious because they're not all equal. They're not all the same. So here's some examples. This is an EPD table from one of our tiles. Now you can see here, this is a very transparent table. A1, getting the material out of the ground, A2, shipping it, A3, making it. And they're showing you the kilograms of CO2 per square meter in terms of how much fossil fuel is used, the biogenic impact, the impact on the land use and transformation. And you can see there that the highest part of the footprint is the A3, the making of the product. And it's at the top right, it's the use of fossil fuel. So a very simple little summary table to tell you what goes on inside that tile. Whereas this one here, they've just rounded everything up. They've just said A1, A3 added together, and there's no rows, it's just all clumped into one thing. So don't always expect to see the same level of information when you look at these things. Sometimes you get extra information. This is quite cool. They're actually giving you the carbon footprint based on the thickness of the tile, which is really useful because it can impact on your overall footprint. Now, when you see the pluses, that just means basically move the decimal point. When it's plus or one, move it one place to the right. It's just a scientific formula to keep all the columns the same width, which we have very, very long numbers with lots of noughts. So we're looking at, for the 9mm one, we're looking at 13.2 kilograms. Now, when you look at this tile, you can see bottom left there, it's now 6.27 to the -01. Now we've got to move the decimal point to the left. We've got to make it smaller. So that is actually 0.627. So if you were faced with making a decision off this EPD, which tile to go for, you may automatically go for the bottom one because it's so low, it's just 0.627. But if you look in the bottom right-hand corner, it says it's based on a kilogram of weight, not on a square meter. So you need to know how to calculate these things. So just remember the backpack. An 8-litre backpack holds 8 litres of minerals, 8 litres of water. Mix it all together, you get a square metre of tile, roughly about 10mm thick, and it weighs about 20 kgs. So we multiply that by 20 kgs, and you'll find that the footprint is very similar to the tile above it. So watch out for all these things, right, when you're looking at EPDs. Now, they're not all equal. Some EPDs are known as industry average EPDs. It's just an industry average representing lots of factories and lots of products. It's vague, basically. It represents many, many things. You get 0.5 of a Briand point, 0.75 of a Briand point for a factory EPD. Now, this is where the certificate's been done for a factory. More transparent, more relevant, more useful for your clients. Much better. The most transparent, the most accurate, the most useful EPDs are these ones. That's where you get 1.5 Briand points. It's because the EPD represents a range. So you're getting to know more about what's going into the actual product. Does that help? So be mindful of all these different versions. They're all around there. And we've got a bit of a split. That's a sort of like the split of the EPDs for our products. And this is what it looks like graphed out. These are all the carbon footprints of our tiles. You can see the ones in the middle. Very flat line, the 11 and the 10.7. They're the industry average ones. You can see we've got some tiles with lower carbon footprints, some tiles with higher carbon footprints. That's what average means, doesn't it? So it really depends on what your specifiers, what your clients are asking for. They want absolute, clear, transparent information. You need to be finding factory and product EPDs, okay? I really want to just talk about this now, about how long tiles last for. If we put a cement screed down, basically a 30 kg, 10 centimeters deep, lasts 60 years. That's the carbon footprint, 30 kgs to start off with. We put some fossil fuel-based carpets down, 15 kgs, last 10 years. Wool carpet, 6 kgs, last 10 years. Linoleum, 4 kgs. LVT vinyl, 3 kgs, both lasting 20 years. And wood, particularly this, because we don't have many solid woods left in the UK now. We get most of them from Europe. This is incidentally from China. So it's a fast-growing light wood, a soft wood, with a hardwood veneer on the top to get that hard finish. That's typically 1 kg lasting 30 years, and a ceramic tile, 8 kgs lasting 60 years. I want to get you thinking about this, life cycle durability. How long is this material going to last for? How is it impacted by sun damage, spillage, and tears? What are the VOCs being generated? They are important. You get the VOC content on vinyls and carpets in the EPD. They tell you what it is. Application processes, how it's going to be fixed. Obviously, maintenance, chemicals, vacuum cleaning, all this material that needs cleaning. Fire risk insurance you already know about. And please think about afterlife. Think about what happens next. Now, I just want to do a very, very simple little demonstration. I'm going to need the lady in the blue scarf. Are you up for this? I'm just going to toss, you just stay there. I'm just going to toss this to you gently, okay? I won't throw it at you hard. When your designers are working on mood boards, and this works for all the materials you're working with, I encourage you to, when you go back to your storerooms, your libraries, look at all your materials, look at all your fabrics, look at how many of them are mixed. I bet you not many are 100% something. I bet there's lots of mixed fabrics there. They're all going to struggle to be recycled. So here's a simple mood board using a ceramic tile and just a polyester mixed carpet, okay, the mix. We build it, we start here. When I go down there, that's the size of the carbon footprint. When I go across here, that's how long it's down for. So we're going to go for 60 years, the average length of the building. So with the tile, this tile here, it'll start with a carbon footprint like this. And over the 60 years, because we should keep it down, we shouldn't replace it after 6 years or 5 years. We should put things in to last because that's sustainability. After 6 years, it would move about this far. And that's because it's got a minimal maintenance footprint. You don't vacuum clean them, you don't steam clean them, you just wipe them down. If there's a spill, you need a mop, whatever, you just mop it. So it's a very low carbon maintenance footprint, very low. Hardly moved yet. You know what I'm going to be doing. Now we're doing the carpet, okay? So the carpet, after 10 years, it would have moved about that far. Because we have to vacuum clean them, we have to steam clean them in certain instances for health and safety. After 10 years, we replace it. There's another install footprint, another carbon footprint for the material, and there's another carbon footprint for burning the old one. It's in the EPD. They tell you what the carbon footprint is for incinerating it. So it's moved up. 10 years passes by, we keep on replacing the carpet. We don't break the cycle. We keep on putting the same thing back in. After 60 years, are you ready? You get it? That's how far it is. 30 times greater the carbon footprint for maintaining it and for dealing with it for its afterlife, because we're talking with something that's not designed to last. If we get our minds around making things to last, we will significantly reduce the carbon footprints in the UK building sector. It's a little bit less for vinyl. It would be kind of where this lady sat here. Linoleum's about here. If you want to see the full analysis, just ask Justin for a copy of my paper. It's a paper that's being presented in June at the International Sustainable Construction Material Conference. It's an accepted paper. It's going to be published, and I'm happy to share it with you. You'll actually see the actual data, okay? So please have a think about that. That's the profile for carpets. It's crazy. Why we keep on replacing them? Vinyl's a little bit worse. I'm not a big fan of OVT. It's on Greenpeace's red list, the vinyl chloride that gets released. It's actually banned in some countries. And I'm a bit of a fan of wood and other durable materials. So please have a think about this in closing. Think about timeless design. It's not just about the material itself, what it is made of. It's how we make it look over time. Now, I'm not saying that the rest of your career, you just design in beiges and grays and whites, whatever. All I'm suggesting is the larger the area you've got to cover, the less risk of something being disliked if it's neutral. Sustainability likes neutral. As soon as we start introducing bright colors, particularly when they're fixed, it's a challenge because the next tenant's coming in or whoever's bought the building, it's a new owner. If they can't live with that, it's like, well, migraine material, it's just, conflicting their brand colors, whatever, it's going to come up and it generates waste. Why should we be treating the UK flooring industry the way we treat our clothes? Next thing, next latest thing, next step colors, next fashion. Can we try and resist it? Because it covers such a large area and it's such a significant footprint. I urge you to think neutral and think durable. Not just ceramics, think about the woods, think about the linoleums. Linoleum's a natural material as well, and obviously cement. Durability is good, particularly when it's easy to deal with after life. Also with tiles, they're very resourceful and healthy. There's been more issues regarding health and safety, obviously with COVID, about ventilation rates. If you're getting into passive house design, which I'm sure you're thinking of, or you may be doing, it's good to keep a nice sealed envelope, getting good airflow currents, yeah? Carpets can introduce buffers. Hard surfaces allow things to flow. Now, I know you've got the echo effect. We can use rugs, not mixed polymer rugs, hemp or wool, yeah? And we can use, as you've got here, acoustic panels to reduce the echo effect. But one of the things people don't realize is that the natural material here is actually a conductor of heat. So in that example there, that's south facing. In winter, when the sun's angle's lower, the azimuth angle's lower, we've got some radiant heat coming onto the tiles. If they're a little bit darker, they'll actually trap some of that radiant heat and you're going to get free convective heating, which is really important around the windows because that's where your airflow currents start to stimulate. It means we're now reducing the heating load because we're getting some free heat. Carpets would hate that. In a very, very extreme case, you heard of OLFs, the unit of smell, yeah? The OLFs can get that bad, depending on what's been spilt on them and whether it's been steam cleaned, where it could potentially lead to sick building syndrome. All right, bacteria can be attributed to sick building syndrome. Now, in summer, the sun's angle's higher, yeah? So we're not getting as much sun coming in, but it's summer, we want that area to be cool. Now, by default, tiles will be cool. You go on your holidays to Europe, it keeps the area cool. You don't get that with the carpets. So I'm thinking here, not just about the materiality lasting a long time, the carbon footprint for maintenance being low, the afterlife concerns being low. We're thinking now of something that can actually add some benefit to the thermal dynamics of your buildings. This is the worst thing we can do. putting wall-to-wall carpets down in the UK. I've already mentioned how much is taken up. Yeah, the area of Birmingham, 75 being incinerated, 75%. Now, if this was a carpet, a full-length carpet, not a particularly good example because of the way things are laid out, but let's try our best. The highest wear points are going to be the doors coming in, aren't they? Because that's where most traffic will be. That's your high traffic wear, yeah? So the carpet will wear down predominantly over there, and then it will just be distributed around the tables. Do you think we've worn the whole carpet down? No. We've probably only worn down about 10 to 15% of the material. Yet because we've created some ugly, wear marks, oh, we can't live with it now, it's all going to come up and get burnt. So that's 75% of that carpet that we're burning every single year in the UK. There's a high chance that between 85 and 90% of it hasn't even been used. And yet we're setting fire to it. It's crazy, folks. We've got to break this circle. It's a real problem. So hopefully this has helped you a little bit understand a bit more about materiality. I've shared this with you because this will be a bit of a guide for you. This is due out very soon. These are the UK net zero carbon performance standard buildings. And it's being driven by all these big names here. They're going to develop metrics used to determine the net zero carbon performance standings. These targets are going to include upfront embodied carbon and life cycle embodied carbon. That's why it's important to remember the mood board thing. You start off, that's embodied, and as you start moving along, you may be adding or taking away embodied if you're replacing things, but all the way along the building lifespan, you're adding operating carbon, which is the cleaning and the disposal. Don't forget that. Carbon accounting approach, how we're going to treat renewable energy and residual emissions. Obviously, they're going to determine how it's going to be validated, and this is really important. There'll be variations. There'll be a residential version, educational, industrial, commercial. And I mentioned before about the UK government signing up to be net zero by 2050. The government has tried to do something, right? This isn't a political argument or statement or anything. It's just, it happened. They did table this. They tried to amend the Building Regulations Act of 2010. Now, that was to actually set pre and post build embodied carbon emissions. Regulate them, and that's what we need. But unfortunately, it's got stalled. The main reason it's been stalled is cast your mind back to those three circles: the social, environmental, economic circle. It's because of the economy. The government's worried that if it was to force regulations and get us to actually build to lower carbon footprints, it could increase building costs. So the environment's taken a back seat. The economy, again, is driving this decision. So hopefully, I've said what I said I've done. Hopefully, I've reinforced how important it is we know this stuff. Hopefully, I've clarified some of these terms and definitions, and that you've got a good feel for the differences of all these materials. I won't dwell on this. We'll send you a copy of the slide, but hopefully, I've kind of like reinforced all these 7 points here, that there's a good story for ceramic tiles. The last one's probably the key one. Why are we dealing with materials that burn and create an environmentally harmful waste? We should be staying away from it. We should be staying with inert materials because they're not causing us any problems, and ceramics are inert. Okay, so one of the things that I just want to slowly, come on, a bit slow this. For us, one of the things that we do, which is quite unique, is we actually measure your carbon footprints for all the samples that you ask from us. So these are all the samples and courier packs that EPR architects have asked from us. So thank you very much for asking. Brilliant, really appreciate it. So the darker blobs are the number of courier runs, and the paler blobs are the number of samples. Any of those projects ring a bell with any of you? You recognize any of those? See any of them? Anybody here wants to put their hand up, knows one of them? Which one's yours? Manor Road. Where are we there? Oh, right, Manor Road. Okay, so you had one sample sent, one package sent to you with 8 samples. Now, the carbon footprint for that was very low. It was like not even a kilogram. So don't worry. Now, remember I said that we exhale around about 5 kgs of CO2 every week? That would work out to be maybe not even a day's worth of stop breathing. So if you want to offset your carbon footprint for the samples, just hold your breath maybe for about 10 hours, you'll be fine. No, seriously, the reason why we do this is we want to track our emissions when we service you. It's not about saying don't order samples. It's really about when you finish with the samples, let Justin know, or your colleagues in Manchester, wherever, and we'll come and collect them and we'll reuse them because we want to keep our footprints low. So we're developing hydrogen ovens. This is really key. We've got 4 manufacturers that are working with this. This is where we're going to actually use green hydrogen, cracking the hydrogen from the water with green resources, mixing the hydrogen with the methane, about a 50-50 mix to try and bring down the carbon footprint by a further 25%. There's going to be more photovoltaic electricity in use. And this is what I mentioned before about, is there a way of not actually wet laying tiles? So this is something that's very new to us. If you want to know more about it, talk to Justin at the end. We're learning about this as we go. But this now is a system where you can actually dry lay tiles using magnetic strips. And this can go on raised access floors. It's got a very thin profile, so it'll almost replace an LVT profile if you want to kick it out and put a more durable material in. Think about fridge magnets, you know, that flexible magnet going on the fridge. Same principle. We're looking 2 flexible sheets. One goes on the substrate, which is going to be lovely and smooth. One goes underneath a tile. A normal tile, nothing special. Ideally a little bit thinner, so it's got a bit more flex. It sticks better. And it can go on walls as well. So it means now, if you've got to do any refits, refurbs, we can move the tiles around. There's a bit of flexibility. So everything we do is driven by the Sustainable Development Goals, and we report using the GRI initiatives. One of the goals we've got as a company is to eventually try and get B Corp certification. There are about 18 architects with this, and we're working towards that, and we will get there. So this is the end of the presentation. I hope you've enjoyed it. I just want to leave you with a couple of thoughts. Right? I love architecture and I love interior design, always been into it, and I would love to have been doing what you're doing. But personally, it would have driven me crazy a little bit, because I would kind of see the job as being like a sculptor. You've actually created something out of your blood, sweat, and creative energy that hopefully, as a sculptor, you want to stay around for a long, long time, because it's, you know, I feel good about this. It's my legacy. It would drive me potty knowing that every sort of 3 or 6 years, things have stripped out because materials have worn, and it starts to look completely different because of the material choices we've made. I'm just going to leave that thought with you. The final thing is, and this is a bit generic thing, throughout life, we get taught to do things better. At school, through all the school, particularly high school and tertiary education, in our social life, very much in our personal life, in sports and at work, do things better. It's like an evolutionary thing. If you just change the order of 2 of those words from do things better to do better things, you'll remember some of the things we've talked about. And that's it. I hope you enjoyed it. Cheers. You got any questions at all? Wasn't too heavy for you? Yeah, all good? Well, look, best of luck to you all moving forward. Hope you're all successes. 100%.